simplify a problem once you find a solution. So that says that, well, before you can do that, you need guesses for a solution. And right now, the reasonable guess to have is, what are the predictions that the rational root estimates? And if none of those work, it's not like you know nothing. You know definitely that absolutely no rational number will be a solution. And at that point, well, I guess the best you can do is use a graph to estimate those. And there are other techniques you can use to estimate. Some of them come from calculus. There are some iterative processes where you can say, well, I think here's a good first guess for a root. You can do some calculus and say, no, this is a better guess. If you iterate that enough times, you can get as close as you want to an actual solution. No guarantee you'll ever make it to one, but you can get as close as you want by doing that. There are a bunch of procedures like that. So this next thing I'm going to hit is Descartes' rule of signs. I'll also often say Descartes' law of signs a lot of times. I believe the textbook says law of signs also, which says the following. Start with a polynomial. This is a polynomial equation you'd like to know something about the solutions to. Descartes' law of signs tells you how many positive solutions you should expect it to have, but there's an ambiguity. So it says there's a polynomial. It says the number of positive solutions to p of x equals 0 is equal to the number of times the sign of the coefficient changes from positive to negative or negative to positive, or that same number minus an even integer. So let's see this in practice. So let's try to predict how many solutions this degree 3 polynomial. That's the same one we did last time. That's okay. We can write it again. How many times do its coefficients change from positive to negative? None. It goes from 3, which is positive, to 2, which is positive, to 2, which is positive. So there are no sign changes. So we'll have no positive roots. So that's a really specific thing for this to tell you. It tells you how many positive roots a thing has. But you can get other information out of this. Let's suppose you want to know how many negative roots a thing has. Well, a negative root is the same as a positive root of p of negative x. So, if you want to compute the number of negative solutions to p of x equals 0, count the number of positive solutions to p of negative x, use the law of signs. Oh, there it is. I'm calling it the law of signs instead of the rule of signs already. So let's use that on this. If I want to know how many negative solutions this will have, I'll plug in negative x instead of x. And it's easy to switch from a positive to a negative, but maybe I'll do it in the intervening step. So p of x is 3 times negative x cubed plus 2 times negative x plus 2. And now let's just simplify. So that's negative x cubed. So that's negative x times negative x times negative x. 2 of the negatives cancel, 1 falls out. The cubing function is odd. Negative 3x cubed. 2 times negative x is the same thing as minus 2x plus 2. So, how many times does that coefficient change from positive to negative or opposite? Once. One sign change. So this has one negative root. So I think there's one other example that I want to hit, just because we haven't seen the full variety of things that might happen as in these problems. Here is a polynomial. X to the 4th minus 2x cubed plus x squared minus 3x plus 1. So let's think about that polynomial. How many times does that coefficient change from positive to negative or negative to positive? 4 times? So, four sign changes. So now we run up against that ambiguity. That tells us that there are 4 positive roots. But we have to read this bit also. P of x equals 0 is equal to either the number of times the sign changes or that number minus an even integer. So it could be 4, could be 4 minus 2, could be 4 minus 4. It couldn't be 4 minus 6 though, right? Because that would be negative 2, and it would say there are negative 2 many roots. 4 or 2 or 0 positive roots. So there is an ambiguity that you'll get. Neat. People feel okay? Any questions right now? So you can get more information out of this still. Same polynomial. And let's summarize what we know about this polynomial already. Let's see what we have on a number line. So if there's the number line, there's 0. I know that there are no roots to the right of 0. I know that there is 1 root to the left of 0. Let's see what we can find out by evaluating the same polynomial at different places. So here's the game you can play. So fix any constant, c. The number of solutions to p of x equal to 0, which is greater than some constant c, is equal to the number of positive solutions to this equals 0. Do you buy that? Right, so if x were a positive solution to this equation, so if you had a value for x which had that equal to 0, well, if x is positive, then x plus c is bigger than c. And x plus c is now a thing you can plug into p to get 0. There's the logic. If you want to find the number of solutions to this polynomial that are greater than c, compute the number of positive solutions to that, which you can use the Descartes' law of signs to do. So let's play that game. Let's expand out p of x minus 1, using a machine or not using a machine, to determine the number of solutions to p of x equals this that are greater than negative 1. So let's see what happens. So p of x minus 1, that'll be 3 times x minus 1 cubed plus 2 times x minus 1 plus 2. And now I'll give people a choice. Do it by hand or use a computer. How many people would like to do the foiling out by hand or see it done by hand? Okay, let's use a computer. Because you know how to foil. You just have to do it 3 times. It's not that hard to do, but... Nice, so let's pull up Wolfram Alpha. So we want to study this polynomial 3 times x minus 1 cubed plus 2 times x minus 1 plus 2. And there it is expanded out. I'll take that and I'll copy it down. Equals 3x cubed minus 9x squared plus 11x minus 3. How many times does the coefficient change from positive to negative or negative to positive? 3 times? So how many positive roots can this polynomial have? 3 or 1. So this thing has 3 or 1 positive root. So what do we conclude? The original polynomial p of x has 3 or 1 roots to the right of x equals -1. So drawing a picture, there's 0, there's -1. Oh yeah, of course you can't see that, sorry. So the conclusion is p of x, and I should probably click here. P of x has either 3 or 1 root to the right of x equals -1. So there's -1, 3 or 1 root. And let's try to combine the information from the previous couple of lines. How many roots does this polynomial have to the right of 0? Cool. So that means that this polynomial doesn't have any roots to the right of 0. So that 3 or 1 root has to be somewhere between -1 and 1. So p of x has 3 or 1 root in -1, 0. Oh, but wait, how many roots total does it have to the left of 0? 1. So could it actually have 3 roots between -1 and 0? P of x has 1 root in -1, 0. Oh, groovy. So that actually accounts for all of the negative roots then. So could this polynomial possibly have any roots to the left of -1? No, they're all accounted for. So see, this can give you good information if you apply it multiple sample points. You discover there was nothing to the right of 0. There was one thing to the left of -1. There was at least one thing, nope, there's one thing to the left of 0. There was one thing to the right of -1. And so that told you something really specific. Somewhere between -1 and 1, there was definitely a root. And that's the only root. How do people feel about that idea? I gave you a way to think about polynomials. And we can now double check that even by looking at a graph, which I think we did last time, but let's pull up that graph again. X. Does that information agree? Does it have exactly 1 root? And that 1 root is somewhere between -1 and 1? Yeah. And Descartes' law of signs told us that that had to be true beforehand. Neat. So the remaining thing I want to do in this note packet is I want to combine all of the tricks that we've developed and study some high-degree polynomials and solve them using these techniques. And I think what I'm about to do might be to ask people to even, oh, God damn it, Chris. To ask people to move so that they have people to walk with. Here's a polynomial. X to the 5th minus 7x to the 4th plus 19x2 minus 47x squared plus 60x minus 46 equals 0. We're going to find all of the solutions to this polynomial equation by following the following thing. Determine how many positive and negative roots. Don't worry about things other than that. You can, if you want, get more options eliminated using Descartes' law of signs at different points. Use the rational roots test to list all of the possible rational roots. Check if they are actually roots. And that's one that I'm definitely going to want people to work together on because there's no reason for one person to do all the computation. For each of the roots you get, do some polynomial long division to pull out a linear factor. Once you have it factored down to something degree 2 or less, you're done, right? So, there's the stuff that I want you to do. And I'll even suggest you can like collaborate with each other. And if two of you want to move to be closer to other people, you can. You can also ask me any questions you want. You can move if you want to.
I think so if you do like you do 5 minus just positive number, so 5 times 1 is 8 and then 5 minus 1. Right? Okay. Okay.
Does that make sense to you? Yeah. Okay, cool. So I haven't explained why they correspond to sizes, and I won't at any point talk this class. But what it says is take this polynomial, and let's count how many times the coefficients change. So that coefficient's positive, that coefficient's negative. So you count that once. Negative to positive, you count that once. Positive to negative, you count that. Negative to positive, count that. Positive back to negative, so there are 5 of them. And then Descartes' law of sign says there's going to be at most 5 positive roots, but there might be that minus 2 or that minus 4. Does the statement at least make more sense now? Yeah.
Good and negative, so yeah, so if it's, I would say like either like a negative x or if it's like an odd exponent, this is going to change the shape of each. So for that one, I have 0.
That should be right. I still 4. Yeah, so that'll make that make yes.
So you can either plug in negative x or number with that negative this actually
Yeah.
so this would have
It should be yes.
Okay.
Also. Yeah, so there should be 0.
So you first put down yeah. Oh, because it's like the PQ. I was going to say, I cannot find it. So that is the
D divided by 6.
Oh, I was right.
yeah. Okay. So it's just gonna be plus or minus any of those. He was wanting you to be over the Okay, plus or minus. So I'm gonna use that. You want to have oh, yeah.
Oh, you put them in for X.
Oh, wait, now you have to.
How do you do that? How do you know that?
Someone has to use that website. Oh.
Yeah. So if we navigate to the crosswalk page, then I guess there's a link. But you can also just go to multiple numbers.
I did yeah. Really?
No, there's not. Yes, a Q over Q, so then and they're all one, so it's just gonna be 1, 2, 3, and just plus or minus. I think there's no fraction. Okay. Plus or minus for each.
So this is just to make sure people are on a consistent page. So it is the case that either 1/2 or negative, or either 1/2 or 2 is a root. Which one is a possible rational root? 1/2 or 2?
2.
2. Okay, good. No one picked 1, right? Okay, awesome. Yeah. Think of it as a constant form, not the leading form.
Oh, I got one. 1 is.
You might use them. No, that's what it's just saying. Okay.
Or just I do 1, 2, 3, 4, 6. That's fine. Yeah, now
Is it dead? Nice. I gotta get a new laptop. I got this one for school. It is not. This one's for 2.
Pretty sure this has a repeated.
12 to. Wait, 9, 12, 18, 26.
No, there's 5 of them.
We've got you.
Oh, you've been hearing that. You can write all. Okay. 3.
Okay, so it's not any of the fours. Okay.
I still don't. Like a regular number, synthetic, no formula. Yeah. Oh, I guess I can. And oh, that's perfect. Four doesn't work.
Oh, I think it's times on 5. Yeah, no, it should be 2. How do we solve so that you more than?
So define the number of negative roots.
Or no, it's the positive, but like more than, you know how like you found one and then you to find
It's
like
like
3 or
2
0.
or 0.
Like you found 5.
Okay.
Yeah.
How do you find more than that?
What's 5 minus an even number?
3.
What's 5 minus another even number? Yeah, so do we shift?
Yeah.
55, it could be 5 minus 2, or it could be 5 minus 4. And then the next thing would be like negative, but that's not reasonable. So
Yeah.
we'll find the
Okay, so, okay. And you do the same thing once you do the negative? To find the multiple. None?
That's 9.
1 and 3?
Oh.
Oh, 1 is, it's not 5, it's 4. It's only 4 cents.
After the division step, I think there's a little bit of discussion on how to do it, but I want to make sure everyone's there for it. Is anyone still at the step where you are determining which of the candidates are actual rational
We
roots?
just finished that.
Okay, cool, that's good. Has anyone not finished this bit yet? Okay, cool. Then, so let's come together a little bit and let's state that result. So which of the possible rational roots are actually rational roots?
1 and 3.
I hear a 1 and a 3. Does that agree? Cool. And maybe we'll come together for some of the things. So how many positive roots does this have? How many negative?
No.
So, just to push one thing forward. So how many possible, how long was the list of possible rational roots? It was kind of long, right?
18?
18. That was including the pluses and the minuses? Are the minuses actually possibilities?
Oh.
So you could have skipped all the negative possibilities. You knew in advance that those ones were there. How many people noticed that before I said it? Okay, cool. That's a thing to note. There's a feedback between the rational roots test and Descartes' solve. Cool. So I have these 2 roots. So that means I have 2 factors. So here's the game plan. So that means I know that this polynomial is equal to x minus 1 times something that I don't know. But that's something that I don't know also has to have an x minus 1 in it, x minus 3 in it, right? So, you can find this by doing synthetic division. This output will be some polynomial. You know this will divide into that. So plug this into synthetic division into that to get what this should be.
I was trying to do it twice.
Well, you do have to do it twice to get this. You need to divide x minus 1 in, then you have to divide x minus 3 into the thing you get out of division.
Okay.
Does that make sense? Cool. And now I'll give people a choice. Do people like the idea of just plugging through this on your end? Is this useful? Okay, cool. Then I'll continue to be quiet for a little bit. Yeah. Yeah. So this tells us that this can't be all of them. We are definitely missing at least 1 and maybe 3 positive roots. Yeah, this was just the rational ones. So there will be some irrational, and some of these might be repeated roots. It might have like 2 factors of x equals x minus 3. So this might be counted twice.
Yeah. I'm just confused on how you found it. This would be
No, you only just did it in theory, so those 2 steps were supposed to both be in this case. So not only does he do it, there might be some repeated roots, so let's talk about that. And let me know what you say. You were going to say something.
Yeah, so do we use 1 again, or do we use the complex?
Let's find out. So, what polynomial did you get in this space?
For the cube?
Yeah.
X to the 3 minus 3x squared plus 4x minus 1.
Could I write down what you said correctly?
Minus 4.
Minus 4. Okay.
Plus 4x.
Plus 1. Okay. Yeah, so the only possibilities this could have for rational roots are 1 and 2. Tell me, so plugging in x equals 1 is easy. If you plug in x equals 1, you get 0 for the Precal Feb?
X equals 1 minus 3 plus 4.
So now we do 3 and
Definitely not. Can I do that by synthetic division? No, do that.
You can do that by synthetic division. So here's a quick trick. If you know you're going to want to divide eventually anyway, if you do synthetic division and get 0 remainder, that tells you it divides unevenly. If you don't get 0 remainder, that tells you it doesn't divide unevenly. So you can combine the plugging in step with the synthetic division step.
I put 1 in there.
Okay, then 1 is not a root of the purple thing.
Oh, the purple thing, yeah. Oh,
So check 3. If 3 isn't a root, then you're stuck. You don't win.
You don't win?
If 3 is not a root, then you're stuck. But hopefully 3 is a root.
Okay.
I did pick this so that it's actually factorized.
Way to spoil it. Thank you.
Sorry. Wait, so then you put 3 into that one too?
It's x squared plus 4.
So you divide 3 into the third degree one too?
Yes.
We got third degree, so you can't solve
And the
that.
first one is
Okay, so x plus. That's the way. Okay, no. So it's yeah, so this way.
Have you double checked so I can note back in? Okay. Do you have, so on things like exams, you definitely won't be allowed access to your cell phone or a
This will
computer.
lead to
If you want to use those, you can pull a full amount of that, and that is much less painful. And I imagine that calculator probably doesn't like thinking about I either, does it? Okay. I guess 2i isn't, it's just purely a math, so it's not too bad. You just have to do it right.
So it would be a conflict. There is a conflict. Wait, so.
Yes.
Yes. So how can we figure out the complex? Okay. Well, we did it.
So he did. Yeah. So what can we take out of that to get x?
Yes, so
X cubed squared.
We heard last time, doesn't know about that at all.
We
Oh, wait. You split them up. Yeah, it's okay.
Wait for the other one. Let me go think about what I want to do the rest of the day. I don't think I want to listen to
Plus x minus 6x.
Oh, sorry. Walk too fast.
So you should be plus of y and
Oh, yes. It's just x.
actually.
We're not doing this right, it's just the x.
we're trying to get the part
Oh,
That makes it a lot easier. It's not like trying to nice.
you just got a nothing plus.
Oh, yeah. I always have
Oh, you're fine.
Yeah, how we're doing. Yeah, it's the nice one, like.
So, let me bring people together and just see how people are. So I know that at least a few people are completely done with this exercise for its entirety. Several people are actually just done with the exercise. Okay.
So that is the positive one. Like positive.
No.
Oh, yeah.
Then,
Two.
No, you should have 3x. Yeah.
Oh, no, these are.
let me start bringing everything together and let's start giving some of the results. So you did some factorization. So, you factored out x minus 1 using synthetic division and you got something. Or maybe you did x minus 3 first. That would be a fine thing to do. It doesn't matter below. Then you factored out x minus 3. And what was the thing you got after you did that division?
X cubed minus 3x squared plus 4x minus 12.
Cool. How many people want that step discussed, getting to there? Okay, people feel good about getting there? All right, so the next step is, this is only degree 3. So you aren't done yet. You can hope that it has another root that you can find, because then you could do division again. What was the other root that the, well, now brown polynomial on the board had?
The degree 2 one?
The degree 3 one.
Oh.
The thing that's written right there.
Wait, what's the question?
Yes, so you did synthetic division twice in this step,
Yep.
and you got down to that result.
Yes.
This brown thing should still have like 3 roots, but it's hard to find them because it's degree 3. But you can find a root. What other root did you find?
3 for 3.
2. Does that, so I want to make sure I'm not just blowing anyone by. So, are people happy with they found 3 as a root? Does anyone want that discussed? Okay, right, you plugged in 3, and you were lucky. So as a result, you could do synthetic division again.
Yeah, sure. Because I know. Just took my math, so then we got this degree 3 one.
And what was the result when you did that synthetic division?
So that's how you know that you can like we did. X squared plus 4.
Oh,
X squared plus 4?
Cool. Did people get that far?
Yes.
Okay, awesome. So once you get that far, like it suddenly becomes easy to set this equal to 0 and solve, right? This form gives you a solution of x equals, this gives you a solution of x equals, and I guess you get the same thing again. And you get 2 other solutions of
Plus minus 2i.
positive 2i and negative 2i. Really? So we came together and went through that quite quickly at the end. Are there any steps that people would like discussed? All right, and with 10 minutes left, I think one of 2 things is the right thing to do. There's another example on the back sheet that we could go through. But I think doing it once, this had all of the subtleties that you're likely to see. So we could do that again, or we could not. Here's the other option. Here is an extra credit on the back page that we could talk about a little bit, asking why does the rational roots test work? And this would give you a head start on doing it, then you would have something to come present to me. So, given those 2 options, another example of solving a polynomial equation, briefly touching on what this extra credit is asking. Do another polynomial solution? All right. And okay, then the other option is that. Cool. So let's talk through this. So here's the motivation. Let's suppose you didn't know the rational roots test, and you wanted to get an idea of what were the candidates to be rational roots of that polynomial. Well, a rational number, maybe I won't go. Maybe I'll do the one that we just did. Give you something to do. Nah, screw it. So whatever the solution is, it's of the form P over Q. So that means that if you plug in P over Q, you should get 0 out. So I'm going to plug in P over Q. I haven't done anything fancy there. And then what I'll do is I'll try to get everything that, well, try to get rid of the fractions. And then I'll try to get a P on its own. So it doesn't have any Q's. If you do that, come on. So that's 14 P cubed over Q cubed plus 4 P squared over Q squared plus 3 P over Q. And I said I would subtract the 15 over to the other side, so let's do that. Nice. So if you wanted to clear all the denominators, what would you want to multiply both sides of this by? Q to the power of 3, right? Q cubed is just hard to hear clearly, I think. So let's multiply both sides by Q to the power of 3. Negative 15 Q cubed equals 14 P cubed plus 4 P squared Q. Right, you would multiply that by Q to the power of 3, but 2 of the Q's would cancel, plus 3PQ squared. Does that step make sense? Nice. So here's the game then. look at everything on one of the two sides, and you'll see that it's divisible by p. Which of the two sides is everything divisible by p? The right-hand side. So that means everything on the left-hand side has to be divisible by p. Well, the left-hand side has to be divisible by p. Well, wait, this is a rational number q over q, so you assume p and q don't have any common factors. So does this q cubed have anything in common with p in terms of factors? No. So that means every factor of p can't be a factor of q cubed. It has to be a factor of minus 15. So every factor of p, in fact p itself, has to be a factor of negative 15. Okay, is that exactly what the rational roots test says? Do you think you could have done this with basically any polynomial to begin with? There's a proof of the rational roots test. So, what do people think? Is the rational roots test maybe now more believable? I hope. Because as we've been using it so far, it's kind of been like a magic. And I guess the other thing is how many people think they're going to walk through this extra credit in all of its detail and then come present it to me? Yeah, I mean, you may as well. Maybe shoot me an email and schedule an appointment. Nice. Okay. Wait. So you have to present extra credit to me. So you have to have like something written down, and then you'll come up to my office and you'll talk me through it and I'll ask you some questions. In order to do that, so it'll be like 5-10 minutes tops is the intention. But if like you show up and someone is also there asking homework questions, the homework question asker will always get priority with the extra credit percent off. And so it might be useful to schedule an appointment to come talk to me sometime outside of office hours. Not saying you can't do it during, just you might not get to. Rudy. All right. People feel pretty good about high-degree polynomials? Nice. And I'm pretty sure that I've gone over by a minute at least 4 times, so I'm okay.
How great weekend.
If I recall, like one of the open-ended homework problems is an awful lot like that report that I had you do today. So hopefully that seems more fair now too.
It's not right. Just rewrite it. You're gonna, what I did before was I just messed up on this thing.
So, I'm gonna be gone at a conference.
I know, that's so stupid. I did the same kind of.
For 3 days. You need like any documentation, so it doesn't hurt my participation.
Which day?
The 19th through the 21st.
Of March, I guess.
And I know I'm missing everything.
Well, I guess the good news is the 21st is spring break anyway. Right, the 19th to the 21st?
No, the 16th, sorry.
Okay, that makes more sense why you're concerned about this, yeah. So you'll miss a quiz, but we'll have you make up the quiz. Send me something that seems like...
It's for McNair, so I can just have them write something out.
If that's the easiest thing, if it's even just like, send me an email containing the conference webpage and saying I'm going to this conference and missing these days.
Okay.
And then close up to March 18, send me an email again so that I can remember to schedule you to make up the quiz.
Okay, sounds good.
Yeah, thank you. No, but we can check them anyway. What solutions did you get?
I negative 2, 3, 1 plus 1 minus 2. It was like
Okay, I asked, but I wasn't ready for them yet. So I'm going to do this. Evaluate x to the 4th minus 3x cubed minus 5x squared plus 13x plus 6 at x equals, what was one of them?
-2.
-2. I guess I didn't even show you what I'm doing. Yep, that looks like good.
Okay.
What's another one?
3.
Good.
And I had 1 plus minus root 2.
1.
Really? I know my brother.
Okay, that's troubling. Because did you say 1 or -1?
I said 1 plus the root of 2.
Oh, 1 plus. Okay, plus. Good.
And then just 1 minus the root of 2.
And a complicated fact about algebra tells me that 1 minus root 2 has to be a solution now. Yeah.
Thank you.
And was that enough that it accounts for all of them? Was it
Yes.
5? Yeah, 4.
4 for that one.
Okay, yeah, and that's all of them.
All right, thank you.
Yeah, thank you.
We have to present this to you?
Yeah. Sorry, if you don't, definitely can do it later. Let me see if I failed to print another page. Oh yeah, I'm staying here. Yeah. No, you're good. No, it's 151. Yeah, so here's what you're going to do. You're going to come by my office sometime, and you're going to just like talk me through why each of those lines follows. I don't want to do it right now because I want to like get mentally prepared for another class.
Absolutely.
Yeah, but I think that all looks like adequate work. I guess maybe like the circle ones you could circle.
Oh, I didn't even realize that there was a circle thing there. Okay, sounds
Yeah.
good. I did there, but nothing. Sounds good.
Cool.
Sweet, thank you. I had the same question.
Yeah, I suspect you two walked it out together though, right?
Yeah.
Okay.
Have we done?
Yeah, you too. Hello.
I'm still confused on what the question is for this.
Yes. So here is, so for unknowns A, B, C, and D, you want to take this fraction and I would like you to do some stuff to it, like the stuff that we did without knowing where these were fixed numbers, to eventually get this down to. Does that make sense?
Yeah, I guess so. I just don't know. I was confused how, like, if it didn't seem to questions, I guess it doesn't matter.
Calculating for this question. Yeah, so, like if this were, asked you to put that into this form, would you be able to?
Possibly.
Yeah, so do exactly the stuff you would do to this to get bigger, but where you don't know what A, B, C, and D are.
Okay. And then also, I'm thinking to know what it is, because
Okay, so it's February 18. Okay.
yeah.
Okay, yeah, I remember your email just, I wasn't, there were things about it, yeah.
Yeah.
Yeah, so tell me what the issue is.
Because, like, it won't let me, like, put fraction in
Okay.
the answer.
Yeah, so a bunch of these will Okay, so this is asking you to find the real term. So what's the number that you actually are trying to plug in there?
2/3.
Oh, okay. Okay, so do you remember when we did complex fractions? There was this trick where you like multiply and divide by the complex conjugate.
Yeah, I did that too, and it when you put in complex fraction. So.
All right. So I think, so you said 2/3.
Yep.
I believe Kansas will only let you enter that as a decimal approximation,
Okay.
but I think 2/3 is not correct.
Okay.
Because I think you got the 2/30 just because this was a 2 and that was a 3.
Yeah.
Okay, yeah, so that's incorrect. So here's how to think about complex fractions.
Okay.
You want to rewrite this in a way that has the denominator being real, non-complex.
Yeah, so it would be 3 minus 6i on the other side, and then bring it to the top, and then multiply those together.
Yeah, yeah.
Yeah, that's what I did, and
And you end up with 2 thoughts?
it was not 2/3. That was my first answer. I tried different.
Oh, okay.
I just don't remember what the other answers I got were. I'll get back to you on that.
Yeah, it's now that I actually know which one you're asking about. So, I think chances are that, I've been recording. So the video that I'm going to post